Hello, welcome to Bradley's Mathematics. This is video 1.3c, the last of 3 videos aimed at worksheet 1.3, prime numbers, highest common factor and lowest common multiples. In the number for GCSE mathematics range, the worksheet is available on my website and I won't waste any time. Let's get straight into the questions. State whether each statement is true or false. Justify your answer. That is important. Justify your answer. If you just put true or you just put false, you're throwing marks away. Please don't do it in the exam. Find a way to justify your answer. So let us see. We start with 1. All prime numbers are odd numbers. Well, I'm going to tell you right away that is well and truly false. Why is it false? Because 2 is a prime number. And like it or not, that is my justification. 2 is a prime number. We know 2 is a prime number. We also know 2 is an even number. We don't have to prove anything. It just is. Okay, let's see what's next. 81 is a prime number. Is 81 a prime number? Of course, 81 is not a prime number. That is false. 81 equals 9 squared. That's all we need to say. You don't need to say anything else. That's full justification. 81 is 9 squared. It can't possibly be a prime number. And last one, 67 is a prime number. This is true. It's shouldn't really have to justify this because it's true, but we'll justify it anyway. Its factors are 1 and 67. Okay, that's all there is to it. All justified, but as I've said, this one, it is a prime number, so actually just saying it is should be enough. Certainly saying this is not enough, and saying that this is false is not enough. They definitely need to be justified. Let's move on. Express 36 and 54 as products of primes. Find the prime factorisation. This is the kind of thing that will be fairly early on your exam sheet. They come up and they come up almost exactly like this, and then find the HCM and the HCF and LCM of 36 and 54. So let's get these done. We seem to be using a sort of a yellowy color here, so I think I'll go with 36. 36, I'll do it like this. 36 is 6 times 6, which is 3 times 2 times 3. Doesn't look like a 3 to me. I don't know about you. I seem to be making up my own numbers there. Times 3 times 2. 36 equals 2 squared times 3 squared. Okay, 54. Let's do this as 3 times 18. Doesn't matter which way you do them, so long as you come up with all prime numbers at the end. 18 is 3 times 6, and 6 is 3 times 2, so 18 is 54 is 2 times 3 cubed. 3 cubed is 27, 2 times 27 is 54. Find the HCF and LCM of 36 and 24. Let's do the HCF first. Okay, we have 2 squared and we have 2, so we have a 2 in there. We have 3 squared and 3 cubed, so we have a 3 squared in there. The HCF is 2 times 3 squared, which is 18. That's the lowest number which will divide into 36 and 54. 18 goes into 36 twice and it goes into 54 3 times. Okay, and the LCM then, the LCM, we have 2 squared and 2, so we take the 2 squared because the 2 is included in it, 2 squared. We have 3 squared and 3 cubed, so we take the 3 cubed because the 3 squared is included in that. And we can say that this is 4 times 27, and 4 times 27, if you didn't know, equals 108. 2 times 54 is 108. 3 times 36 is 100. Is it 3? Yeah, is 108. So the lowest number that 36 and 54 will both divide into is 108. Move on again. A red car and a blue car drive round a racetrack at constant speeds. The red car completes a lap every 2.5 minutes. The blue car completes a lap every 3 minutes. If they start at 0900, what time will it be when they next cross the start line? Okay, let's start with looking at 2.5 minutes. 2.5 is not a natural number. When we're working with highest common factor, lowest common multiple, prime numbers, prime factorizations, we are working with natural numbers. So we have to change 2.5 into a natural number. How would we do that? This is 2.5 minutes. There are 60 seconds in 1 minute. There are 120 seconds in 2 minutes. So there are 150 seconds in 2.5 minutes. Let's do this in our blue there. So we have, let's do it in red actually. The red car completes a lap every 150 seconds. Now we'll go to blue. The blue car, we have 3 minutes. We have to change that into seconds as well. 3 times 60 is 180. So the blue car takes 180 seconds to complete the lap. Now we do our prime factorizations. Okay, back into red for the red car. 2 times 75. 3 times 25. 5 times 5. So 150 equals 2 times 3 times 5 squared. Back into blue for the blue car. 180, we have 2 times 90. 2 times 45. 3 times 15. And 3 times 5. So the LCM here for 180, sorry, the prime factorization for 180 is 2 squared times 3 squared times 5. Now, We're looking for what time it will be when they next cross the start line together. And we're working in seconds at the moment. I just want to point out, we cannot be looking for an HCF. 180 is not a multiple of 150, so the HCF is lower than 150. You're looking for the time when they have completed so many laps that they come back together again. This is an LCM problem, a lowest common multiple problem. We're looking for the lowest common multiple. So let's do this in a neutral color. The LCM is, we have a 2 in the red car, 2. We have a 2 squared in the blue car. Which one do we take? Lowest common multiple, we take the 2 squared. We have a 3 in the red car, a 3 squared in the blue car. Which one do we take? We take the 3 squared. And we have a 5 in the blue car and a 5 squared in the red car. This time we take the red car, we take the 5 squared. This equals 4 times 9 times 25, which equals, let me just quickly bring in my calculator. Okay, we're looking at 4 times 9 times 25 equals 900. This is 900 seconds. So let me write that there. 900 and 900 divided by 60 equals, oh, it doesn't let me carry on the calculation. Never mind, let's try again. 900 divided by 60 equals 15. Okay, I didn't realize it would do that. Equals 15. Now, let me just get rid of my calculator. There we go, that's that gone. It equals 15 what? 15 minutes. 15 minutes. Okay, it equals 15 minutes. They start at 9 a.m. So they are together 15 minutes later at 09:15. Okay, that's it from this video. You've got all 3 videos in the series. Look at them as many times as you want to. Don't forget that the worksheets are available on my Bradley's Maths website. Thank you for listening. Please take the time to like, subscribe, and leave me a comment. Thank you very much. Okay, bye-bye.